Good morning everyone. I am Pallavi. Today we see the example based on the bisection method. In the previous video we have seen that what is the bisection method and algorithm of the bisection method. We know the bisection method, it is the method to find out the root of the given equation. See the example. Find the real root of the equation x cube minus x is equal to 11 is equal to x cube minus x minus 11 is equal to 0. We know our first step is we have to choose any 2 points such that the product of 2 points is less than 0. That is, find the 2 points a and b such that f of a into f of b is less than 0. If suppose we take the point 2 and 3, f of 2 is equal to minus 5 less than 0, f of 3 is equal to 13 which is greater than 0, and the product of these two function f of 2 into f of 3 is less than 0. That is, we can say that our root lies between 2 and 3. So we take the average of 2 and 3, we get x0. So x0 is equal to 2 plus 3 upon 2 is equal to 2.5. Then evaluate f of x0, that is f of 2.5 which is equal to 2.125 greater than 0. We know the number of roots is equal to the degree of a equation. Here the degree of equation x cube minus x minus 11 is equal to 0. That is, it has 3 roots, so you can choose another 2 points. Then we get the root of the given equation other than 2.3 or 2.37. So we compute f of x0 which is equal to 2.125. Our second step is decision making for replacing 2 or 3 with new value. X0 is equal to 2.5. We know f of x0 is equal to 2.125 which is a positive value. So f of x0 is greater than 0, then x0 2.5 replaces any one of 2 and 3. We know f of 2 is equal to minus 1, minus 5, f of x0 is equal to 2.125, both has an opposite side. That means we can say that root lies between 2 and 2.5. So x1 is equal to 2 plus 2.5 upon 2 is equal to 2.25. Next we find out the 2.25. f of 2.25 is equal to minus 1.859375 which has a negative sign. Then x1 is equal to 2.25 replaces any one of 2 and 2.5. We know f of 2 is less than 0 and f of 2.5 is greater than 0. Therefore we can say that the root lies between 2.25 and 2.5. So x2 is equal to 2.375. See the example in the tabular form. N is equal to 0, our first iteration. A is equal to 2, f of a is equal to minus 5, b is equal to 3, f of b. Both has an opposite sign. So we say that the root lies between 2 and 3 which is equal to 2.5. Find out the f of 2.5 which is equal to 2.125. f of 2.25 is equal to 2.125. It has a positive sign. Then we say that the root lies between 2 and 2.5. Taking its average, we get the value 2.25. Then find out f of 2.25. We get minus 1.85938 which is its negative value. See the above iteration f of 2.5 has a positive sign. Therefore the root lies between 2.25 and 2.5. Taking the average of these two numbers, we get 2.375. Again find out f of 2.375 which is equal to 0.0214 which has a positive value. In the above iteration 2.25 has a negative value. Therefore the root lies between 2.25 and 2.375. Taking the average of this, we get the value 2.34375. Again find out the f of 2.34375 which is less than 0, negative value. In the above iteration 2.375 has an positive value. Therefore, we say the root lies between 2.34375 and 2.375. Taking the average of this, we get 2.359375. Repeating this procedure at the end of the example, we get the constant value up to 3 decimal point 2.375. So, we say that therefore the root of the equation x cube minus x minus 11 is equal to 0 is 2.373, correct up to 3 decimal places. Thank you.